Hi everyone, today we're looking at scanoss-py. It's a powerful command line tool used for software composition analysis. Now, it's both a Python library and a command line interface, which helps you scan your codebase for open source components, dependencies, and license compliance. Here's how it essentially works. So scanoss-py uses the winnowing algorithm to create unique fingerprints of your source code. These fingerprints are then compared against the SCANOSS Knowledge Base, which contain information about millions of open source components. Your source code never gets sent to scanoss. The only thing that's transmitted are the fingerprints. So this means you can analyze your code for open source components, licenses, and vulnerabilities without ever exposing your source code. Everything stays on your machine. The beauty of this approach is that it doesn't just look at the declared dependencies, it actually scans your source code to find embedded open source components that might not be in your package manifests, all while keeping your code completely private. Alright, so let's install scanoss-py. So what I've done here is I opened up my terminal, and you'll need Python version 3.9 or higher, and you can check the version of Python you're running by typing in the following command, python ---- version. As you can see, I'm running Python 3.1.2. And the easiest way to install scanoss-py is from PyPy using pip. So just type in pip install scanoss. As you can see, scanoss has successfully been installed with version 1.52. Now, if you'd like faster scanning performance, you can install the fast winnowing extension for scanoss, which is pip install scanoss winnowing. Now, to verify that fast winnowing is active, what you can do is run scanoss-py utils fast. As you can see, fast winnowing is set to true. For dependency scanning from package manifests like package.json, requirements.txt, or pom.xml, you have to install ScanCode Toolkit, and you can do so by typing in pip install ScanCode Toolkit. Perfect. You can take a look at the available commands by running scanoss-py --help. This will show you a list of the available commands. So you have version, scan, fingerprint, dependencies, container scan, file count, convert, component, crypto, utils, results, inspect, export, folder scan, folder hash, and delta. Before we start scanning, let's talk about API keys. For basic usage, you can scan without an API key against the OSSKB knowledge base, but you'll be limited to the number of scans you can perform and the metadata in the results file. To unlock full features and enterprise capabilities, you'll want to get an API key. So I'm just after opening up a project in VS Code which I'd like to scan. And additionally, I've opened up the terminal, and you can run a scan with your API key as follows: scanoss-py scan --key. I've set my API key to an environment variable, so I'm mentioning that scanoss-API_key. Set the output to results.json and mention the folder you want to scan. So in my case, it'd be source. Give that a second. Now, as you can see, the scan is successfully completed and it has scanned 7 components from this project. So let's take a look at the results and see what we get back from a scan. Opening results.json, we can see that the output default is in JSON format, and it gives us comprehensive information about each component that was scanned. So looking at the results, what we can see here is file level information, such as the file path itself, the file hash, and moving down, we can see that the match type here is a snippet match. Going further, we can see any license related information, so the detected licenses and any copyleft information. Going further, we can see the matched lines from my file to the actual original source code files. So my ones would be 69 to 476, and then the original source code would be 8 to 415. We also get a match percentage, and moving further, we get the related pearls, the relevant URL from the original source project, and the relevant vendor information. Now, this metadata would be displayed for the rest of the components as well. As you can see, index.js contains the component information here, the file hash, hits, match type, snippet, lines that match to, match percentage, OSS lines, any related pearls, source URL, the relevant project URL, vendor information, and so on for the rest of the components as well. Now, in case you'd like to scan a single file and not your entire project, you can do so by running scanoss-py scan --key, mention the API key, -o to output the results file, single file.json, and then mention the file name, so source, and in my case, I'd like to scan index.js. Perfect, and as you can see, we've successfully scanned one file. Now, if you'd like to scan both the source files and the declared dependencies for your package manifests, what you have to do is type in scanoss-py scan -- dependencies -- key scanoss API _ key, output the results to a file, and then mention the path of the project. And if you only want to scan for dependencies and skip scanning the source code files, what you can do is type in scanoss-py scan dependencies only, mention the scanoss API key, mention the output file, and then mention the project location. So for large projects or CI/CD pipelines, you might want to separate the fingerprinting step from the scanning step. And to generate the fingerprints, what you have to do is type in scanoss-py fingerprint, mention the output .wfp, and then the location of the project. As you can see, it successfully wrote the fingerprints to the file name called project.wfp. Now to then scan these fingerprints, you can run scanoss-py scan, mention the API key, --wfp, mention the fingerprint file, and then output it to results from wfp.json. And as you can see, we get the same results as we did previously in results.json for each of the 7 components. Now, scanoss-py supports multiple output formats to fit into your existing workflows. The available formats, as I mentioned, are JSON by default, CycloneDX, SPDX Lite, and CSV. Now I can generate the SBOM in my desired format by mentioning it during the scan. So scanoss-py scan, mentioning the API key, -- format. In my case, I'm trying to generate a CycloneDX SBOM, mention the output, SBOM.json, and then the project location. As you can see, clicking into the results file here, the BOM format is CycloneDX. scanoss-py also includes a convert command that transforms your existing JSON results into the relevant supported formats. So in this case, I'm converting the results.json file to an SBDX Lite format. As you can see, it's producing the SPDX Lite report, and then clicking into SBOM SPDX.json, we can see that the SPDX version is SPDX 2.2. So now let's look into the scanoss.json settings file, and it lets you define your project-specific scanning behavior, such as file filtering rules and bill of materials management settings that persist across future scans. If we go to the root of our project here and create a new file called scanoss.json, we can include the following block to add any project-related information. So you have the self, name of the project, the license type, and the description of the project. You can expand this by including a settings section which configures the scanning behavior. In this case, I added the following packages folder to be skipped during a scan. So now when I run a scan with the following scanoss.json file inside of my source folder, it just skips scanning all of the files under the packages folder. As you can see, it's loading the settings files from source scanoss.json, fingerprinting, and then scanning only 2 components. So looking at this results file now, we can see 2 components, index.js, which is in the main source folder, and then going down we can see tests/index.test.js. What's important to note is that both of these components are undeclared. As you can see, the status here is pending for index.js, and the same thing for the second component here, meaning that we still need to make a decision about these components. To further confirm that they're undeclared, what we can do is type in scanoss-py inspect undeclared -i results.json. As you can see, it mentions that one undeclared component was found, so we have to add the following snippet into our scanoss.json file to make our decision and declare the component. Now that we've declared the following component, now we can verify that the components were all declared by rerunning the scan again and observing the results.json file. Looking at the new results.json file, as you can see scrolling down, the status is changed to identified for both of the components. Now, based on the previous results file, you can further add the following filtering parameters to further filter out components that you do not care about. So in this case, I'm adding in min snippet hits 117. Looking at this first component, we can see the snippet hits were 116. So increasing that value by 1, we're filtering out this component. Min snippet lines 408. If we look at the matched lines, we can see that 69 to 467 is 407, I think. And adding one more value to that, now that filters this component out completely as well. Setting ranking enabled to true and setting a ranking threshold. So this controls whether the origin project score quality is taken into account during the matching. And the closer the value is to 0, the better the project is maintained. Then I've also enabled skip headers to skip any license headers, comments, and imports at the beginning of files, and also declare the maximum number of lines to skip when skip headers is enabled. You have that control as well. Now, on top of include rules, you also have exclude, remove, and replace rules, and this is a sample of how you would actually utilize them also. And that's pretty much it. That's how to get started with scanoss-py, how to declare your scanoss.json file, and how to read your results. Thanks so much for watching.